In July 1919, whalers from Vancouver Island hauled up something that terrified them to their core. At first glance, it was a 27-ton female humpback whale, but when they looked closer, they saw that she wasn't like any other whale. She had legs. Not fins or flippers or flukes, but unmistakably legs. 2 of them. Each more than a meter long, jointed at the knee with skin like leather and ending in a round stump that looked like a human fist. Was this some kind of sea monster, like they read about in their Bibles? A bad omen, a washed-up creature from the ancient past. The shell-shocked sailors sent letters to the world's leading whale experts in New York, but even they were clueless. Never in recorded history had anyone ever seen or heard of anything remotely like it. Until one scientist called Roy Chapman Andrews had an idea. What if this wasn't a freak accident, he said, but something much more deliberate? What if those legs weren't random, but a throwback to a long-forgotten time? When reptiles ruled the ocean, forests grew in the Arctic, and whales walked on 4 legs. And now, in 2025, a flurry of recent discoveries has made it clear he might just have been onto something. I'm James Stewart, and you're watching Astrum Earth. Join me on this journey into the whirlpool of deep time as we search for the bizarre ancestors of the largest creature ever known and come face to face with one of evolution's most elusive mysteries. Whales are, quite literally, the biggest enigma on Earth. They migrate across entire oceans, communicate over hundreds of miles, dive to depths where light doesn't reach, and live for entire human lifetimes and even longer. The first clue is hidden inside their body in the most overlooked part of their skeleton, their flippers. We might assume they're just lumps of cartilage, but what's really inside them is much more unusual. 5 colossal individual fingers. Weird as it seems, whales actually have hands concealed in their flippers, like they're wearing giant fleshy oven gloves. They're eerily human-like, complete with complex arm, wrist, and finger bones. This 5-finger pattern is called the pendectal limb, and it's a common feature of animals that didn't evolve to swim, but to walk, like cows, horses, dogs, monkeys, and of course, humans. Perhaps even stranger still is a set of bones that are free-floating, unattached to any other bones, ligaments, or muscles. They don't do anything for movement or support, but they just sort of sit there. These are actually vestigial hip bones. You can think of them as the bits evolution forgot to get rid of. They once had an important job to do, but as conditions changed, they were no longer needed. It's like how we still have a coccyx, or tailbone. Our primate ancestors had long tails to help them balance on tiny branches, but as we adapted to life on the ground, we didn't need them anymore. So over time, our tails disappeared, but the bone they attached to stayed behind. This is because a tiny bone at the bottom of your spine doesn't really affect your chances of survival, so evolution had no real reason to get rid of them. But if the human tailbone is left over from a tail, vestigial hip bones in whales point to one thing: a time long ago when whales did indeed have legs. Even before Darwin's time, early scientists noticed these vestigial features. They knew that whales were mammals because they were warm-blooded, nursed their young, and breathed through lungs, not gills. So it made sense that if you went back far enough, you could find whale-mammal ancestors that lived on land. But for decades, there wasn't a single scrap of fossil evidence to prove it. But then, in 1831, the mystery began to unravel after a landslide in the backcountry of Louisiana. Days of heavy rain on the dry earth caused an entire hillside to give way, and the freshly exposed earth was rich in ancient marine clay and crystallized minerals, and peppered with prehistoric shells. But it wasn't just shells and rocks that emerged from the mud. There were bones, too. Huge, curved bones, vertebrae the size of tree stumps, ribs the size of a full-grown man, and sharp, flesh-tearing teeth. The bones found their way to Richard Harlan, the top paleontologist in the area. And in a stunned letter to the American Philosophical Society, Harlan said they'd found the bones of an ancient sea monster. The American public was enraptured, and a few years later, punters flocked to New York to gawp at the 30-meter-long skeleton of the same creature which was shown off as a biblical leviathan from the time before Noah's flood. When Harlan studied the skeleton, he noticed similarities with plesiosaurs from the time of the dinosaurs and concluded that this monster had to be an ancient marine reptile. He called it Basilosaurus, or king lizard. But a few years later, Harlan brought the bones to his friend Richard Owen, a world-leading naturalist in London. And Owen spotted something everyone else had missed. The monster's back teeth were double-rooted. For a reptile, like Harlan had proposed, this was all wrong. This wasn't a reptile, Owen concluded. This was a primitive mammal, on a scale never dreamed of before. Without realizing it, Harlan had found the first ever prehistoric whale, a colossal predator that terrorized the ocean 40 million years ago. Over the next few years, scientists found more and more skeletons of primitive whales from the same time, like Dorudon, a sleek, torpedo-shaped predator that looked like a giant dolphin. Scientists could now picture the sea 40 million years ago, teeming with dozens of species of ancient whales. But as they continued to piece together the evidence, they noticed nearly all of these whales had one strange thing in common. Sprouting underneath the back part of their bodies, there were small, flipper-esque nubs like the start of tiny back legs. So, in 1919, when those Vancouver whalers from the start of the video found a humpback with legs, Roy Chapman Andrews was certain. The protrusions actually do represent vestigial hind limbs and show a remarkable reversion to the primitive quadrupedal condition. In the search for the elusive walking whale, scientists were finally getting warmer. By the late 1900s, all the evidence seemed to point toward prehistoric whales that walked on land. The only thing missing was a fossil to prove it. But nothing could have prepared scientists for what was found next. Let me give you a hint. If you were to go right up to a whale today and look it square in the face, you'd see something strange dotted around its jaws. Whiskers. In 1978, fossil hunters from the University of Michigan arrived in the Suleiman mountain range in Pakistan, hundreds of kilometers from water and nearly 1,000 meters above sea level. Millions of years ago, these soaring mountains were the shore of a great prehistoric ocean, the Tethys Sea. Led by Philip Gingerick, they were looking for ancient mammals, and after weeks of digging, they found a fragment of bone they'd never seen before. It was a broken skull. They could tell it belonged to a small animal that lived 50 million years ago, and the pattern of the skull showed it was a mammal. But they had no idea what it was. Even Gingerick himself, a specialist in mammal paleontology, was at a loss. When they returned, they got experts to reconstruct the rest of the skull the best they could from the fragment, following the pattern of a typical mammal. What they were left with was a skull roughly the size and shape of a wolf, with long, snouty jaws and sharp teeth. But this wasn't any ordinary mammal. The eye sockets were weirdly close together and placed high up on the skull. The positioning of the eyes was more like crocodile than a land mammal. Strangest of all was what they found in the interior of the skull itself. A tiny S-shaped bone in the ear. This bone, which develops to help animals hear underwater, is called an involucrum.
And it's unique to only one kind of mammal, the whale. And at that moment, the penny dropped. This small, strange, dog-like creature was the world's first ever whale. But with only a small fragment of skull to go off on and a reconstruction to the best of their abilities, there was still so much scientists didn't know. Over the next few months, the fossil hunters found more bones, and piece by piece, bone by bone, this 50-million-year-old whale began to come to life. Clearly, this whale had 4 limbs, and its back limbs seemed to be longer and more robust than the little nubs found on Basilosaurus and Durodon. This was tantalizing evidence of walking on land, but they still couldn't know for sure. That was until they found one special bone in the back limbs called an astragalus. The astragalus is a kind of ankle bone, and all mammals with 4 limbs have them. But compared to those of later whales, this creature's astragalus bones were different because they were clearly built not for swimming, but for walking. So, at last, after hundreds of years, scientists had the answer. Definitively, this was indeed a whale that walked on land. Gingeric called it Pakicetus, and it's one of the strangest-looking animals you could think of. Imagine a creature about the size of a wolf standing up on 4 legs with a sleek body covered in fur. It has a long, pointy, awkward head that looks like a cross between a greyhound, a rat, and a crocodile, if you can picture that. Oh, and it has a tail and feet that are like those of a dog. The ear bone said Pakicetus was a whale, and the ankle bone said Pakicetus walked. But scientists still didn't know what actually was it. Where on earth did such a strange creature come from? The answer went back to that ankle bone, the astragalus. See, most mammals have what's called a single pulley astragalus, which basically allows your ankle to move in all directions. But its finder noticed Pakicetus had a special double pulley astragalus, which restricts movement to one direction. This is useful on land because it more or less makes it impossible to twist your ankle. Now, there's only one order of mammals that has this unique type of ankle bone. They're called artiodactyls. Generally speaking, these are mammals with hooves like pigs, sheep, cows, antelope, giraffes, hippos, camels, deer, and now, of course, whales. Scarily, it may have taken us millions of years, loads of paleontologists, and thousands of hours of work to track down Pakicetus, but you just know if Pakicetus had any online presence whatsoever, those pesky data brokers would sell him out to the nearest prehistoric predator in an instant. I like to think of data brokers as the gossipers of the internet, going around the place collecting your personal info, selling it, and spreading it around like it's the latest drama. That's why you get spam calls, creepy ads, and the constant barrage of messages reminding you that no matter how much you spend on a racket, you still suck at your new midlife crisis hobby, paddle. Enter Incognito, your personal data bodyguard. It hunts down those sites sharing your info and tells them to delete it. Plus, with their unlimited plan, you can send in custom links like, "Hey, my info's on this random site," and poof, it's gone. Think of it as hitting the disappear from the internet button. What a dream! Much like our prehistoric friend here, they can't scam you, stalk you, or spam you if they can't find you. Try Incognito risk-free for 30 days, and with my code ASTROMEarth, you'll get 60% off annual plans too. Click the link in the description to make your data as extinct as the dinosaurs. But how in the world did this strange little creature turn into the majestic ocean whales we know today? To find the answer, we need to look more closely at its home, the shores surrounding the Tethys Sea 50 million years ago. It's rocky and arid, except for a few shallow streams and lakes. It only rains a few times a year, and food is hard to come by. Pakicetus uses its long snout to hunt for washed-up fish on the shores. To make things worse for Pakicetus, Earth's climate is also getting hotter. As the continents continue to drift further apart, new ocean currents are forming, carrying with them warm water and air from the equator into the polar regions. These warmer poles result in a warmer planet. So along the shorelines where Pakicetus lives, food is becoming more and more scarce. If Pakicetus wants to survive, he needs to find a new food source, fast. Luckily for Pakicetus, although the warming climate makes food harder to find on land, it contributes to an explosion of life somewhere else, in the water. So for the first time ever, Pakicetus dips his toes into the water in search of food. And in the warm shallows, he finds an abundance of fish, plankton, and other small sea creatures. And so, with this seemingly trivial change in food choice, Pakicetus kickstarts one of the most extraordinary evolutionary journeys in the history of our planet. More than 300 million years after the first animals crawled out of the water, the very first whale crawls back in. But after solving one problem, Pakicetus now faces another, because there's more lurking in the ancient Tethys Sea than just fish and plankton. Pakicetus is primarily adapted for living on land, which makes him a slow and clumsy swimmer. To get around, he has to paddle like a dog. This makes him a sitting duck for prehistoric predators, like giant crocodiles and sharks. So within a few million years, Pakicetus is snuffed out from the fossil record. For the scientists piecing together the story of whale evolution, it was like their flame had been extinguished. What if Pakicetus was just an evolutionary dead end, a weird land mammal that wandered into the sea only to be stamped out by predators for good? After all, Pakicetus didn't look anything like the next oldest whales, Basilosaurus and Durodon. If Pakicetus was the grand whale ancestor they hoped for, there had to be a missing link. 16 years after Pakicetus was found, a student of the finder called Hans Thuesen went back to the mountains of Pakistan. In rock dating back 49 million years, he unearthed the back leg of an unknown mammal. The next day, he found its vertebrae and some ribs. Finally, on the third day, he found a fragment of skull. But he still couldn't tell what it was. It was long, much longer than Pakicetus, with a sleek spine, slender fingers, and sharp-toothed jaws. Its legs were sturdy enough to support itself on land, but the hind legs were wide enough to be flippers. Could this be the missing link they were searching for? There was only one place to look: the ear bone. If it had the same special underwater ear bone as Pakicetus, they would know for certain if it was a whale. And sure enough, it did. Thuesen had found the next link in the chain of whale evolution. Pakicetus didn't die out, it evolved. He named this new creature Ambulocetus natans, which means walking, swimming whale. In his own words, they had finally caught evolution in the act. So how did the land animal Pakicetus evolve into Ambulocetus, the walking, swimming whale? To escape the jaws of crocodiles and sharks, Pakicetus's tail got thicker and developed muscles like an otter. Its back legs got shorter and wider, acting like flippers. Its body and skull got longer and more streamlined. This same pattern continued for the next few million years. Whales' legs got shorter and more flipper-like, so they got worse at walking and better at swimming. In just a few million years, it seemed like whales were ready to take to the water entirely. In 2009, Philip Gingrich, the original finder of Pakicetus, struck gold once again. And by gold, I mean Maiacetus, a primitive whale from 47 million years ago. Despite living just a few million years after Pakicetus, Maiacetus's limbs are shaped almost entirely for swimming, not walking. The body is long, streamlined, and, at a glance, fully optimized for life in the water. And yet, Maiacetus has one surprising secret, which shows the first ocean whales might have been more attached to the land than we previously thought. When Gingrich unearthed the first Maiacetus fossils, the first thing he found was small teeth, which he assumed were those of a small adult whale. But as they continued to expose the fossil, they found ribs that were unusually large, far too large to go with those teeth. After a full day of digging, Gingrich realized something extraordinary. This wasn't just one skeleton, but two. The big ribs didn't belong to the owner of those small teeth, they belonged to its mother. Gingrich had found a pregnant mother whale with her baby almost fully developed and ready to be born. While this was an amazing find in itself, Gingrich realized there was something even more curious about it. See, when aquatic whales give birth, they do so tail first to prevent the newly born baby from drowning. But inside this Maiacetus, the fetus was positioned completely wrong, as if it was about to be born head first. And there's only one class of animal that gives birth head first: land mammals. This indicates that 47 million years ago, even though whales spent nearly all of their time in the water, they still used their short, stumpy legs to haul themselves back onto land to give birth. It's like how sea turtles still crawl back onto land to lay their eggs. Maiacetus is fascinating because it's the best image we have of an aquatic, swimming whale actually standing up and walking on land. So how did whales go from this to becoming the full-blown sea creatures we know today? By the time Basilosaurus and Durodon arrived 40 million years ago, whales were clearly fully aquatic, creatures that fed, mated, slept, and lived entirely in the water. Their nostrils had moved up their nose to the top of their head, creating a blowhole. They traded in their front legs for flippers, leaving behind those bony fingers inside. And their back legs, which had previously fanned out into flippers for swimming, started to disappear until they were reduced to vestigial stumps. But if those flipper-like back legs previously helped them swim better, why did they disappear? Why didn't whales end up with paddling back flippers like turtles? The answer comes down to one incredible piece of swimming equipment that blows flippers out of the water, and surprisingly, comes directly from their land-dwelling ancestors. The whale's gigantic tail is one of the most glorious swimming adaptations in the entire animal kingdom. Around 40 million years ago, at the time of Basilosaurus and Durodon, whales' tails started to stretch out into what's called a fluke, basically a giant paddle. Over time, these tails grew and grew until they became the majestic tails we see on whales today. It's in fact these mammalian tails that actually make whales such phenomenal swimmers, able to traverse the world's largest oceans and dive miles below the surface. Ironically, while this may seem a far cry from the doggy-paddling Pakicetus that first dipped his toes in the water, the way a whale swims is actually much closer to Pakicetus than you might think. Those powerful up and down strokes of the tail that whales use are actually an underwater echo of how their ancestors moved on land. In fact, it's the same for almost any mammal with 4 legs. Imagine a cheetah bounding across the African savanna, a horse galloping across an open field, or even a dog darting after a tennis ball. If you look closely at the movement of their back, you'll see the way their spine curves up and down with each stride. This pattern is called undulation. And oddly enough, if you look at a whale swimming through water, you'll see the exact same shapes in their spine. Fish and sharks, on the other hand, swim side to side with vertical fins like the rudder of a boat. But whales, with their massive horizontal tail, swim up and down like a mammal bounding on land. This is because whales inherited that same land mammal backbone that was designed to flex up and down with each stride to help them run faster. It just wasn't designed to bend sideways. Think about your own spine. You can curl your head forwards or stretch it back, but twisting it side to side feels much less natural. So when Pakicetus got into the water, he brought that land-based equipment with him. That means the way a whale swims is, in a way, a distant memory of what it was like to bound across the shores of the Tethys Sea all those millions of years ago. From the furry Pakicetus, to the walking, swimming whale, to the land-birthing Maiacetus, to fully aquatic Basilosaurus and Durodon, at last we've arrived at the modern whale. But to finish the story of whale evolution, there's one final question to answer, which scientists have puzzled over since records began. Why are they so big? While there have been the odd species of giant whale here and there since the time of Basilosaurus, it was only 5 million years ago that whales grew into the giants we see today. For some reason, at that exact time, whales across the world's oceans simultaneously exploded in size. Sure, since they got in the water, they freed themselves from gravity so they could grow without being crushed under their own weight. But why did they balloon so suddenly 5 million years ago? What was the trigger? Well, around the same time, Argentina and South America were splitting from Antarctica, causing a shift in ocean currents. This led to massive blooms of plankton, krill, and small fish. So, with such an abundance of food, whales were free to grow and grow. On top of this, there are actually advantages